Welcome to homework.
Problem 15.222 of the book Kinematics of Rigid Bodies. We have a plate which is rotating in two ways. One of the frequencies is along this axis which is attached to the plate, and the other one is about this point over here. So the one about the axis is omega 1, which equals 9 radians per second, and omega 2 equals 12 radians per second. So we can immediately see that omega 1 will make this point go inwards into the plane of the paper, and omega 2 will make it fly in this direction, and these two directions are perpendicular to each other, so we can work them separately. We want to find the velocity at this point, which they call point B. So we'll break it into components. Now this direction given in the book, in the question is x, so they call this as the x-axis. So this one up here is the minus x, so velocity along minus I cap, we say, which is the minus x direction, it is equal to the angular velocity which is responsible for that, which is 9 radians per second, multiplied by this distance, which is equal to 0.135 meters. So this comes out to be this is the I velocity. Now let's also put in the other velocity. This direction is the z, so we call it k cap. So similarly we have 12 radians per second multiplied by 0.135 again, which is this length. So this is equal to using the calculator, we find that this is minus 1.215 I cap plus 1.620 k cap. Now this is in meter per second. Of course, I've been ignoring the units so far. I cap, and these many meter per second k cap. So now we also want to find the acceleration of point B. In this case, the easiest way, since the velocity is perpendicular to the direction of motion, the easiest technique to find it is the centrifugal formula, which is acceleration equals v square upon r, where v is the magnitude of the velocity and r is the magnitude of the distance. So the magnitude of the distance we already know as 0.135. Velocity's magnitude can be calculated from the velocity. So that is equal to under root of the x component square, which is minus 1.215 square, plus the y component square, which is 1.620 square, Now this is the velocity, so v square by r, v square will be the square of this. So the square cancels out the under root. So we are simply left with this portion. And this, using the calculator, comes out to be 30.375 meter per second square. If you include the units correctly, meter per second here and meter for this one. So this is the answer.